Well, good morning, geometry students. I hope that you're having a great first day of distance learning. I'm Mr. Barton. I'm going to go over some proofs, questions with you. I've had some questions already about proofs, some requests that we go over a few of those. So I'm going to go over a few from our EOC study guides. This is directly from the EOC study guide from the Georgia DOE website. In fact, if you Google Georgia DOE EOC study guides, you'll see a list of those study guides here, and we are going to be working in the Geometry EOC Study and Resource Guide in Unit 2, Prove Geometric Theorems. I'm not going to read all this to you because I know that you could pause the video and read over some of this, but you see our standards at the top. You see some key ideas in regards to two-column proof, paragraph proof, information regarding an auxiliary line, and then some theorems that you learned about earlier in the year. Our vertical angles theorem, our alternate interior angles theorem, which relies on parallel lines, which you see there, our corresponding angles postulate, which again relies on parallel lines, our triangle angle sum theorem, our isosceles triangle theorem, our triangle mid-segment theorem, as well as points of concurrency: in-center, centroid, orthocenter, circumcenter. You could Google those if you'd like definitions. Also, you can see some key ideas about parallelograms, mainly that opposite sides are congruent and opposite angles are congruent. Diagonals of a parallelogram bisect each other. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram, and that's often key within a proof. And a rectangle is a parallelogram with congruent diagonals. And then, of course, you know, we could add an extra one there: a square is a special rectangle. So let's take a look at a couple items that deal with proof. I'm going to scroll up in this document here, and we have a couple questions. In fact, we've got one here that deals with a two-column proof. Use this triangle to answer the question. So we have this triangle GIK. Said this is a proof of the statement: if a line is parallel to one side of a triangle and intersects the other two sides at distinct points, then it separates these sides into segments of proportional lengths. Okay? Basically what this is saying is if HJ is parallel to GK, then it separates the side GI and KI into sides of proportional lengths. Okay? Well, if you notice the proof, and this is actually how this often ends up, quizzes, tests, and other assessments, but you see a two-column proof here with the steps outlined to the side. So you actually have a third column that outlines the steps in numerical order, but then you have your statements and your reasons. And essentially you're just asked to fill in this reason here. To be quite honest, you don't even really need to look at steps 3 through 6 or even step 1 to come up with a reason for the congruence between angle IGK and angle IHJ, as well as the congruence between the angle IKG and angle IJH. So let's look at the figure, and I bet you the figure will give us a clue as to why we could say that these two pairs of angles are congruent. Well, if we look at angle IGK, so we've got angle IGK, that's this angle here in red. And then we have angle IHJ, that's this angle here. Then I'm going to change colors. And we've got angle IKG. I'll use two markings there. And then we've got angle IJH. Why are these angles, the angles in red and then the angles in blue, why are they congruent? Well, if we scroll down, we're going to be given some choices. Well, the choices there are alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, and vertical angles are congruent. So real quick, you can see the answer there. But real quick, let's figure out what these things mean, because we might need to review quickly what we're talking about here. Let's see if I can get rid of what I've written over here. So let's get rid of this off the screen. So I've got parallel lines. I'll do my best to draw some straight lines. May or may not work out well. Not too bad. I'm going to cut those parallel lines with a transversal. Okay, these are parallel lines. I'll go ahead and put a little marking there. And we've got a marking there. Well, in red, I'm going to mark out angles that are alternate interior angles. This angle here would be an alternate interior angle to this angle here. These angles are on opposite sides of the transversal, interior to the parallel lines. These angles are congruent. We also would have a pair here. Okay, we'd have a pair on this side. Alternate exterior angles, I'll mark those, I don't know, in green. These angles are exterior to the parallel line, so these are on the outside, on opposite sides of the transversal. Guess what? Those are also congruent, so these are congruent as well. Corresponding angles are congruent. I'm going to mark these in, I don't know, orange. This angle here would be corresponding to this angle here. So we've got those corresponding angles marked in orange. You could also have corresponding angles. For instance, I'll draw this here. That would be corresponding with that there. We could also have corresponding angles in this case. So we've got a lot of corresponding angles, right? So I'm going to get rid of those for a moment, though. And then we also have vertical angles. Vertical angles are congruent. I'll mark those in a different color. Let's go with black. So vertical angles, I always like to say those are angles that make an X. This angle here would be vertical to this angle here. Those angles, if you notice those lines make an X, they're on opposite sides of the X. Vertical angles are always congruent. You don't need parallel lines to know that vertical angles are congruent. We actually use supplementary angle theorem and things like that to prove that. So, with that said, you saw these different types of angles. Let's go back. Let's go back up to what we had a minute ago. And if I remember correctly, we had IGK, IHJ. So we're going to erase what we've got here. And I'm going to go back and mark these. I can't remember the colors I used, but I believe I had red on this side. And I believe on this side, I had these angles here. Well, what sort of angles do we have? These are our parallel lines. I've got the red, I've got the blue. Think back to what you just saw. Hopefully, you could draw the connection there that says that those are corresponding angles. Those are corresponding angles marked out there by the parallel lines. And so the answer here would be C. Corresponding angles are congruent. Okay, so like I said, directly from the EOC study guide, corresponding angles are congruent. That would be letter C right here. All right, let's see what else we have in here that we could go over that would help us with proof. I believe we got a couple questions down here dealing with congruent triangles. Well, if you remember, we have quite a few congruent triangle theorems, and also when triangles have been proven congruent, we know that corresponding parts of congruent triangles are congruent. So we have the angle-side angle theorem. You've got a picture of that here. Let you pause the video and look over that. We have side-side-side theorem. And I've got a picture of that here where all the sides are congruent. You could pause and look at that. We have side-angle-side theorem. We also have angle-angle-side congruence theorem. And one that was not included here is we also have hypotenuse-leg theorem, which deals with right triangles. That's a special form of the angle-angle-side. Actually, it's not angle-angle-side. It would be side-side angle. It works as long as we have right triangles. It's not included here, but if you have a right triangle and you have a hypotenuse and leg congruent, you know that those right triangles are congruent. Let's look down at a problem. Let's see. Here you go. Consider the triangles shown. Which theorem or what can be used to show that these triangles are congruent? So think back to those theorems we had. You had angle-angle-side. I think you had side-angle-side. You had side-side-side. What other theorems did we have? We had angle-side-angle. And then, like I said, we have hypotenuse and leg. So you got a lot of options to prove triangles are congruent. Which one can be used? Ignore this over here. That popped up on its own. That's from earlier. Get rid of that guy. So what theorem could be used? Well, I've got two angles here, congruent to two angles in this triangle, and then I've got a side. Two consecutive angles and a side. Two consecutive angles and a side. That looks a lot like angle-angle-side theorem. So those triangles are congruent is I have two angles in this triangle congruent to two corresponding angles in this triangle, as well as a side congruent to a corresponding side here. So we could use the angle-angle side theorem to prove that to be congruent. All right, let's get rid of that. Let's try to move down the page. What additional information is sufficient to prove that triangle DEF is congruent to triangle JIH? Knowing that DE, segment DE, is congruent to segment JI, so this is congruent to this, and we know that angle D is congruent to angle J. Well, it would be really nice if DF is congruent to JH. That would give us side, angle, side. Side, angle, side. So let's see if DF congruent to JH is down there. Well, it looks like we have a lot of segments. So do any of those say DF congruent to JH? I don't see that down there. So let's see if we can find a different side. Well, it might be that they sneakily told us that DF is congruent to HJ, because if you notice, we do know that HF is congruent to HF by the reflexive property of congruence, right? And if you notice here, this one's kind of weird. They said DH, so DH is congruent to JF. And we already know that this is congruent. So what that means at the end of the day is that DF is congruent to JH, which we already knew. I mean, if that's true, that would help us prove these triangles to be congruent. But if we know that DH right here is congruent to JF, we already know HF is congruent to itself, then we know this full segment JH is congruent to DF. So actually, sneakily, they snuck that one in there on us. The answer to that one would be B. Let's see if there's another one in here that we can knock out real quickly. My time's going to be up. I think we've got another proof here. Here's some examples of proofs. You could go back through there and look at those. Yeah, here we go. I'm going to pause the video and let you look at that real quickly. Alright, so in this one we want to prove that two triangles are, we want to prove, and let's see if you can see that here, we want to prove that AC, segment AC, is congruent to segment BC. Well, in order to do that, we're going to have to prove two triangles are congruent. Okay, so we're going to have to use one of our triangle congruence theorems. Well, we know that CD is the perpendicular bisector of AB, so then we know that these segments are congruent here, AD and BD. We know that CD is congruent to itself by the reflexive property. Sometimes I put a couple markings there just to let you know this is congruent to itself. And we know that ADC and BDC, those angles, those are right angles, and therefore they're congruent by definition of perpendicular bisector and the fact that all right angles are congruent. So I've got side angle side congruent to side angle side. Well, that sounds a lot like the side angle side congruence theorem to me. So hopefully that's one of our answer choices. So as we scroll down, I'm going to have to click off of here to scroll down real quick. Yes, it looks like, let's get rid of those things here. It looks like we've got the side angle side congruence theorem, letter C. All right, so let's take that off. Let's go down real quick. We've got one more I think we can run through. There's the question there. Go ahead and pause the video, read over that. All right, so in this diagram, STU is an isosceles triangle where ST is congruent to UT. We see that here. The two-column proof shows that the base angles, S and U, are congruent. So I went ahead and marked out what the proof shows. One, we already know that ST is congruent to UT. I constructed an angle bisector, TV. We know that these angles are congruent by definition. We know that TV is congruent to itself through the property of reflexivity, okay, the reflexive property of congruence. So I know that these two triangles are congruent by side, angle, side. Well, when we know that triangles are congruent, how can I show that particular parts are congruent? Corresponding parts, congruent triangles are congruent, okay, and that's a capital T right there. Corresponding parts of congruent triangles are congruent. Anytime you've proven triangles congruent, the very next step is typically going to be CPCTC. I love CPCTC, and look at that, it's right there for us to select. Let me get rid of that other stuff. The answer is letter A. I hope this video helps you out with proofs. Shoot me an email, shoot me a message on Remind if you have any questions working in iExcel on those proof standards. And we'll talk later.